on the vcamp, and now I'm going to do the same. So once more, welcome on programming technology. Next lecture related to programming technology. And as I said today, the agenda for today will be discussed. This discussion will be definition of structured data and feature of the structured data. What is the most important thing is related to the structured data. Of course, structured data we are using context of databases. But let me ask the first question related to this topic. Remember that we must get back to the basic rules related to the grades of your activity, and you can get only there's according to this rule you are getting points, only 1 point for one question. So try to answer the question as precise as possible and as fast as possible. I try to select only the best answer and the first answer. The best answer, but according to the sequence, only one will be selected. But the question is first. The question is if it's possible to use the file to preserve structured data. Yes or no? Do not provide description. Just answer the question, because on the screen we can see that we are talking about structured data in context of databases. Usually we are recognizing databases as external repository, data repository that we can use to save, to maintain external data. Therefore, the very important question is how to use the databases. Of course, we'll talk also about object relation model. It is very important how to deal with the software, with the program. Actually, how to talk about accessing external data in context of the language terms. Let me recall that I'm still trying to press you to use only the terms that we can find definition in context of the language, but sometimes actually in two cases we are using external terms. One in case we are talking about abstractions, about algorithms. For example, today someone says me that in program separation of concerns have been used. Of course, but separation of concerns is abstract term. It's just idea, is a concept, but it must be implemented somehow in the software. Therefore, it is very important thing to talk about external concepts like, for example, MVVM, like layered application, like separation of concerns, but in terms, using only terms that we can derive from the language, directly or indirectly. Usually we are trying to explain directly, use directly terms. But object relation model is the second example where we must to harmonize our description in context of the language, because in context of the language we need to talk about the external things like a database, external data repository. Usually we are talking about database, but in general we must talk about external data repository, because XML file it is also a repository. But most of you answered the question that yes, we can use files. We can use files to preserve, to save structured data. Of course, we haven't defined what the structured data is, yes, but we'll get back in the context of the code, because I think that the code is the most important thing here. But if you see possibility to use files to represent structured data, the question is about the condition. Where to select database, but not the file, in case we are going to preserve something outside of the program, outside of the process. Now we are talking about the runtime, not design time. In the design time, we must decide if we are going to use database or we are using the file. Maybe sometime we can provide a layer of abstraction that allows us to use database like files and vice versa. Actually, I have a lecture called Adaptive Technologies that we are using this approach. In this approach, we need to provide a layer of abstraction to make sure that we are just saving the data. Doesn't matter if it's used, if the layer below, if the concrete layer is using databases or is using files. LINQ to SQL is a special construct, special concept that have been implemented in the language. We discuss about it a lot, about the LINQ. It is a language integrated query. But now let's try to discuss about special edition, special implementation, we can say. Special implementation of language integrated query. Let me recall some rules we have defined during the previous lecture related to the language integrated query, because I still can observe that you have problems how to answer the questions that we are dealing with the language integrated query. That something that we can see in the code, we can call language integrated query. How to distinguish language integrated query from any other construct. I hope you have answered the answer for the previous question, but let's go to the next question. The next question, the next question is related. Don't try to answer this question because it's related to the code, and I must open the code. But let's try to recall what is the difference between structured data or any other kinds of data. So now we need to provide details about the definition what the structured data is. So let me go to the code, to the example code, and try to find this interface, because it's interface. As you can see, there is a lot of projects, your projects, after the laboratory, and here we can find in my code, in the example code we are using during the lecture and using the rest of the classes. Let's close all tabs and just start from the very beginning. For us, the most important thing is structured data folder. Structured data folder, we can find a definition of this interface. ICD catalog. And the question is if it's structured data. If any class that derives, that inherits this interface must be recognized as the structured data. Here we have a few properties It is country, price, title, and year. And as you can guess from the name, we are going to use this interface to represent information related to the CD catalog, relation to the CD, information about the CD that we are collecting in the catalog. So, if now the question is if it's not structure, because I can see only one answer, maybe there's more, but let me ask another questions. And in the another questions, we are referring to the I person. And the question is similar. If a type derived from the I person interface is structure from the definition, Okay, you can stop because only the first answers are important. So provide only answers. It's different. I must to return to the basic rules of the assessment of the grades because I can see that you are copy the previous answers, and if the previous answers it's okay, you are also getting the point. So now it's impossible. Now only the first correct answer will be used for grading. But the difference between two definitions, let me split the screen. So on the right side you can see ICD catalog. No, it is not structure, it is complex data, because to get access to the parts, we need to use selector. And we have selector in all of the cases. In all of the cases, we have selector. Additionally, in string case, because string actually it is reference object, but still we have selectors for the string. So it is not enough to say that if you are talking about the reference type, we are talking about structured data. It is especially important because in databases, usually we are using string as a value data. It is not reference. It is not reference type. On the left side, I person there is no doubts. Here we have reference to IEnumerable object. IEnumerable means that it's a set of entities that must implement ICD catalog, and additionally the set it is so we can there's sequence defined. We have get next, so we can define for any entity that belongs to the set the sequence, the next one. But on the left side, we are talking about the graph. The graph means that one object refers to another object, and to get access, for example, to items in the ICD catalog, we must browse. We must use reference. We must browse and use reference. So it is definition about between the complex data and structured data. It is very important in case of databases. In this tool, there is Server Explorer, and in the Server Explorer, we can define databases. There's an example. CD catalog is an example of the database. And looking inside, diving into details of this database, we can see that we have two tables, and the tables provide similar information as we have in the types. Actually, now the types are not coupled together with the databases. Database is something something independent. In my code, the database, so you can see that we have a few rows. It is a table. It's definition of the table. Definition of the table, and we have rows. And actually, in the table, because it's table, we need to talk about the column. Sorry, it is columns, but in case of the real table, we must also talk about the rows. And there must be relationship between this term. So let me ask the next question. That relates to the database. What is the main result of establishing a connection to the database? It is just one word. Do not provide any description. Sometimes it's very important to use just a word to avoid wasting time and describing something. So here we can see that we have tables. The tables have columns. Each columns have type, data type. And we can see, for example, here that for the string, we can use varchar type. It is equivalent. It is more or less the same like a string, but here we are talking about the value, not about the relation, about the reference. Of course, there is reference between items in the table, but let me discuss it later. Let me discuss it. But to get access to this database, I need connection. So what is the main outcome? I will answer this question. Let me ask the next one. What operation are conducted during the login to the database? Because connection, it is related to logging to the database, to log into the database. Of course, after establishing connection to the database, we are creating not connection string. We need connection string to get connected to the database, but we are creating session. It is the most important thing that we are creating here, because the session we will use all the time. We are getting access to the database. What is the reason to use the session? That is the next question. But what operation? No one knows. Let me ask. Oh, someone writes. So let's wait for a while. Here we have person and we have CD catalog. As in the previous example, we have two tables. These tables are related with each other. The relation we can see on the independent picture. But it is very important thing here. What is difference related to the code? Here, this artist key, it is integer, but in the database we can allow null values. So it is nullable values. Of course, in language we have similar concept. We have similar syntax that we can express that a value could be null in case that it is value type. In case we have reference type, always we can use null. There's no need to provide any additional information. Okay, so go to the next question. Next question is, what is the role of the session? One word. What operations are conducted during the login. Actually, we need to talk about two operations. First is authorization. Authorization is to prove authority, to prove that someone that tries to get access to the database are well known, and so actually we know identity of the user of the database. Next, we must approve. We must use next operation. It is authorization. Authorization, let me recall and put this on the paper. That authorization, it is answering the question if the operation, if the selected operation is allowed for a person, for identity. So first operation, it's dedicated to answer the question about the identity, and second one is the identity can is allowed to make operation. What is the operation? Operation is opening the session. It is the operation. If the user is allowed to open the session, to create the session, because as I said, the session is the most important thing we are talking, if you are talking about the database. Next, it is very important thing, so let's stop talking, and next question we have: what terms defined in the context of the database must be mapped on program constructs? So here we are talking about the relationship between the program and the database. As I said previously, we need to define this relation. We call it mapping. We call it mapping. It is object relation mapping. Sometimes we use this term object relations mapping. So we must know how to talk in context of the language about the terms we are using on the database. In this case, I am expecting 6 identities, 6, maybe 5, not sure. But let me get back to this question and explain it in details later. But answering to the previous question, what's the role of the session? The role is to keep hold information about the user. So the session keeps identity of the user as the most important thing, because all operations that we are requesting from the database by sending, for example, queries in the relational databases must be proved, must be tested, so must be so the authorization, we must use authorization to prove that the identity holding by the session is allowed to execute this operation, to execute this request for the database. In we are talking about the relational database, we are talking about queries. So we are approving the query. It's possible. Its query is allowed for the user. But so in the language, there's many concepts we can use. In many concepts we can use to get access to the databases. Let me close all of that. One of the concept we call language integrated query. Language integrated query, and here is an example. Creating language integrated query, we need to add new create new item, and in new items, probably you know this because it is required in this in the second task, but some Not all of you are using language integrated query. Actually, language integrated query, it's technology. It is a framework. It's not only the framework, it is also a tool, because it is embedded design window, design table here, in the Visual Studio. But it is not required that we are using this design tool inside the Visual Studio to get access to the database using language integrated query. But my question is, for now, uh, my question for now is, what happens if you are creating object, we are creating picture like this? The picture we can create by moving the tables from this server explorer on this design window. After moving, we can recognize that here it is. We can also have relationship between the tables. It is one thing that we need to represent in the code, but it is related to the database. We need relation between items in the database, and we must map this relation on the relation in the context of the code. But answering to this, the previous question, what we need to map, let me ask next question that prepares us to the next topic. What information must be represented by the connection string? Talking about the connection, we are talking about the connection string, and there's three items, three entities that must be represented by the connection string. But what happens after moving the table here, after creating this nice picture? Under the cover, we are creating this class. The class calls, if you are using this code, the class code catalog designer C# code. We can it's possible to just to read that it is auto-generated code, but probably in your homework you have proved that the classes have been created, but it is tricky point, because the class is auto-generated by the tool. It is simple to forget about it. It is simple to forget that actually the databases and all of the entities in the databases, all of the elements that are used to build the database must be mapped somehow into the program. First thing is how to prove that we are mapping database as the one whole. So answering to the previous question, from the 6 entities, the database, it is the one thing that must be represented in the code. Of course, in the code, the only thing we can use to represent something, as usual, it is just a class. Here, catalog data context is generated as a representation of the whole database. So all operations that we are going to execute against the database must be in context of this class. Sometimes you are calling it data context. Of course, data context in terms of the language means nothing. Okay, it means it is name of the next class. So actually, talking about the data context, still we are talking about the classes. We must derive our custom class from the class provided by the framework. Using this technology, we are using this framework. Go to definition. is useful to prove that we are getting this from the additional assemble, from the assemble that we are referring to. We are using a definition from. So it must be added to the references in the project to get to use the types defined by this assemble, by this framework. Here we can find all the details, including public key token, to make sure that our code is compliant with the selected framework. So it is okay, but inheritance, it is not enough to make the relation, the mapping. The mapping is here. The mapping is here, but it means, not that it means, we are using attributes, database attribute. It is attribute that we are using to point out as a prefix of a class that must be used by the environment as representation of the database. If you are talking about the databases, relational databases, all the operation against the database are represented by this catalog data context must be realized, must be executed as queries. Therefore, we need a code that is responsible to convert all our execution of our operation in context of the code. But in context of the code, what we need? In context of the code, we can also execute, for example, properties or methods. It is the only way to express, not only, but it is an example of operations that we are using to inform our class and to inform the framework that something must be done against the database. The something must be converted to the SQL queries, because accessing the data and managing the data, maintaining the data in the databases, in the relational databases, we need to use SQL language. Okay, so this attribute says that it is representation of the database. Previously, I said that the next thing we must represent, talking about the structured data, we must represent information about the structure. How to represent information about the structure in context of the language? For example, let's see on the CD catalogs entry. CD catalog entry should provide information about similar to what we have in the table CD catalog. And in the second CD catalog, we have ID, title, country, price, year, artist key. So all of this information. The question is, if it's structure, here we have year, it's short, price is decimal, country is string, and title is also string, ID is integer. So here we are not providing structured data. We do not have provide any information about the relationship between the items. Let's examine now the it was CD catalog. Now it's person. In person, yes, in person, for example, we have entity CD catalog entity. It is this property provides this relationship. in the language, the relationship between the items are references. We are using, of course, it refers to all of the object-oriented languages. If you are talking about the object-oriented languages, structure and dependencies in the relation between objects, we are implementing using only the references to the object. And here it's not an example, but still, how to say the environment that this relation must be used in the database as the foreign key, because in the database we don't have references, we have foreign key. So it's the second item, foreign key is second item that we must map between the database and the code. Here is also the attribute. Using this attribute, we can say that this is a relationship between person and CD catalog entity. There's more more information how to implement it. This information actually it is used by the environment for. It's a good question. Why the environment are using this information, this data? Because it is, we can call attributes as a metadata. Metadata means that we are describing the data. CD catalog entities, it is just a data. It is production data. But this association attribute, it is a metadata. It says only how to implement CD catalog entities as in terms of the database on the relational database. Of course, the answer could be only one. That we are using, not we, framework are using this information to create SQL, to create SQL queries. Because the queries must be created by the framework. But framework must have all the details about how to create SQL, queries. After creating these SQL queries, the query could be sent to the database, and after that could be executed by the database, provided we have connections. So all the queries must be executed in the context of the connection. Therefore, this class catalog data context is responsible to provide. So what the context means in terms of interaction with the database, it means connection. It means that on the database side we have identity. We have identity of the user that we can use for authorization. And on the software side, we can convert all the actions in the program to the SQL queries that can be sent to the databases, executed, and the data, from time to time we can return the data. So to get access to the persons table, we need to use this property. We need this property. And actually this property needs that it is table, persons table in the database. Let's look on the persons table. What is represented by the person table? Persons table, catalog entities, persons table, it's persons. Let me show it, structure persons here. Persons table, it is representation of the, let's think about it. What is represented by the person? It is represented, it says table. Of course, it's not table. It is row in the table. So we can say that the class represents the table, and actually here we can see the rows of the table, columns of the table, first name, last name, age, etc. But actually the person element, person object is a value of the row, of one single row. Of course, because all of the rows need the same columns, so must be represented in the same properties. Here, for example, first name is represented as a string. We can get this information also from the database definition, persons table. We can see that last name, first name, all of are strings. Here we have first name and last name. So it is the second, it is the second, third items, third identity we need to map on the software. It is the table. Second, next one, it is the row of the table. It must be represented by the code. And next, all the types that we are using on the database, there's no even the names could be different. For example, here first name is navchar, and in the code we have just a string. So there must be conversion between the representation bit string, bit stream that represents the value in the database on the bit stream that are used as a value inside your program. There might be also mapping between the types, and there must be conversion between the types. Okay. What operation we are... So here's object relation mapping. So let me ask the question, what is the role of the... Let me summarize this discussion. What is the role of the object relation mapping at design time? What is the role? Okay, let's try to answer this question in simple words. Just a few words, it's enough to summarize what I said. Actually, everything was said, so this it is not something that you must answer in advance. It is something that you must just summarize in a few words what I said during explanation of the object relation mapping is. But let's get back to the LINQ to SQL. Let's get back to the LINQ to SQL. First, we must ask about the operation. Actually, we are executing against the database, external databases. Usually, we are using operation like creation of new items in the database. In terms of the database, we are talking about insertion, operation insert. In terms of the language, we are calling about create new. Second operation is modification. Something exists in the database. We are providing some modification and pushing back to the database all the modification. Next is delete operation, where we are deleting existing items. And next operation is just selection. Selection the data. As I said previously, it is this operation. Actually, it is something behind the language integrated query, because language integrated query was created. Let me recall the example we have here. I think it is in this class. This class is partial class that is I have added manually to the catalog data context. Let me record the catalog data context is something that represent a database. Represent the database. I've added something, and here we can filter person by license using for each operation. It is first example. Second one is we can use from construct for the similar purpose. What is the difference? Difference is that in this case, we are applying selected operation to all of the items that we can get from this variable, from this object. On the right side, we have object. It could be expressions and returns object implementing IEnumerable. Therefore, for each we can be applied to IEnumerable entities, IEnumerable objects. Here, the requirement is exactly the same. As I said during the lab, it's easier to use this syntax. We call it a query syntax, where we are using special keywords to express. It is expression. So we are constructing an expression using keywords. But let me recall from the previous lecture that the compiler, before compiling the code, converts this expression into the method call syntax. So it replaces this expression using the method syntax. Okay, so as I said, we have 4 operations, but the operation select, it was something that it is the background. It is a basic operation for this idea, for the language integrated query. Here we are selecting, and after selecting, we can apply an operation for the selected operation. It is different from this, where we are applying to all of the items that we can find in enumerable. But we must find another operation. How to map this operation on the database? How to insert a new object? It's easy, because let's go to this. Let's go back to the catalog designer. We can see that the persons and the CD catalog entities are of the type, and so it is table. Let's look on the go to definition. Let's look on this. Here we can find operation attached. It is not add, or it is also not insert. Insert means that we are adding new row to the table. Here we are talking about attaching. Let me recall to the next question, because it's very important here. What is the role of object relation model at runtime? Previously, we have answered, trying to answer the question, what is the role of this ORM at the design time. So answering this question, we can say that it is representation of the database. It is in terms of the language. And we can use this. How we can use this representation? Why we need this representation? We need this representation because at the end of the day, we need to send, for example, to the relational databases query query that are using SQL language. So someone, in this case framework, must convert our operation into the SQL queries. Must convert it. So need all the information how to do it. All the details that we that are required to make this conversion, to create this conversion. Next question before answering what is the role at the runtime. Let me ask the next question. It is what terms defined in the context of the database must be mapped on program? It is. I think it has been asked this question. So neglect this question. Answering to the previous question, attach means that here we are talking about the cache. It is something like a temporary memory. So adding to the memory representation of the database, not memory representation of the database, of the object model, we are adding new item, but it doesn't mean that we are adding new row to the table. Therefore, we are talking about the attach. To make sure to convert it to the SQL and sending all this modification to the database, we can get back to the definition of the data context. And the data context, where is the data context? Catalog data context here. Go to definition, and in the definition we can find operation. Let me change it to the go to definition, not pick definition, and here it'd be easier to find the operation submit changes. We need to use this operation. As you can see, the operation, this method is provided by this basic class data context we are using to provide mapping between the language, between the terms we are using in the language and terms we are using in context of the database. Using submit changing means that all the modification of this object model have been converted to appropriate SQL queries, not only one. It could be many queries, and all of the queries will be sent to the databases. And in these databases, the queries will be executed, and the result will be returned to the software. So submit changes actually it is used to make insert operation in the database that sent modification we have made. Here is the designer. But in the designer, as I said, we need table. Go to table definition here. In the table, we are using attach. It is only information. We are going to add something to the table. We are going to do something, not we are editing something. We are doing to do something. After using the submit changes, everything, every modification is converted to the SQL queries and sent to the database. Of course, if you are talking about the relational databases, in case we are using different external data repository, it could mean something else. But in all of the cases, object relation models or mapping or just object model that we have in the memory and we are creating against the database, we are using as a cache. We are using as the cache. Okay, so the next question is relating to the question relates to this to the link to SQL, but because we need to go back to the SQL, how to implement access to a new external repository in the context of the LINQ concept. How to implement. For example, try to imagine that you need to provide functionality. You need to do something like in this assemble. This assemble was created by Microsoft, and it's created by Microsoft and actually provides all the functionalities that it's required to get access to the database. Actually, it is just a class, but here is information about the framework, about the assemble. We have only one assemble. The assemble could provide many definitions, but in any case, some operation must be mapped. But now I am asking only about the language integrated query, because adding the new item to the database, new row to the table, do you mean it is something in common with language integrated query? We are using just a method attached. Where's the example? For example, it's in the catalog. Here it's my part of this database representation. You can see that for each, we are using here for each, and we are adding it's called not this one, the first one, add content. Add content is an example how to add items to the database. The database at the very beginning is empty, and using add contents, I am adding the content that is provided by this parameter, by the person. So this actually enumeration. And as you can see, we can insert or submit. We are using insert of submit here to get access to provide information. So we are using just the method that we are inserting new object. Next, it's at the very beginning, at the end, we are using submit change, and in this place, in this sentence, we are calling a method that is responsible to convert all the modifications to the database and send SQL queries to the database, and making sure that all the queries have been executed. Okay, how to prove that we are dealing with the database? How to prove that we are using language integrated query? Remember that we are using language integrated query only for selection. For insertion, for deletion, and the rest, we are using just method calls. Not special construct. It's everything we know. But of course, this method must know how to convert, must learn from the object relation model how to convert the operation into the SQL operation. First, how to prove that we are using language integrated query? We are using the syntax. It's easier to use this syntax because from the syntax we can see that it is related to the language integrated query. We can use it only for the language integrated query, this syntax. Of course, we can use also the method syntax. And in most cases, I can remember related to your code, you are using methods to provide the similar functionality. The rules are exactly the same, but uh, here it's easier because we can see from the syntax that we are talking about language integrated query. The very important things for this syntax, or for the method syntax, here, not here. Here we have syntax, query syntax, and here we have exactly the same syntax, but exactly the same semantics, the same meaning, but different syntax. Here we are using method syntax. Where is a method? Let me prove it. Pick, you can see it is just a method. Of course, it is extension method, but for us here doesn't matter, because let's talk about it. It's easier. First, talk about the conversion, because I think it is not clear for you. Conversion means what this words mean. For example, what the where mean. It means that we need to use method where. On the right side of the where, we have delegate. It looks like expression, like condition, like expression that returns true or false, because equals means that it's that actually we are returning true or false depending on the last name and this last name. So we are actually comparing two things. Last name, it is a parameter of the methods, and last name, it's something that we can find in the definition of the persons. By this, we are talking of the source database. Source data. It is variable, this expression. Actually, it must return an object that implements IEnumerable. Let's prove it. So let's go to definition of the persons here. We can see that it's property. So it must return an object, because table, it's a reference type. Go to definition. We can see that really the table implements IEnumerable. If it implements IEnumerable, we are talking about language integrated query. It doesn't matter if the language integrated query it's against the real database, it is against in-memory database, it's against the file, it's against the object. It is just language integrated query. It is required by language integrated query to, it's this example. I have lost this file. Let me pin it. Okay. It is required. So actually we have two requirements. First is required that we have this syntax. Second, in this syntax, this method or this expression, actually this object returned by this expression object must implement IEnumerable. The same is here. Here we can prove that this one it is data representation variable or value, where we can use as a source of data, but it must implement IEnumerable, because all the methods we are using in the language integrated query must be extension of the IEnumerable. And it is exactly in this case. From this example, you can see that here we can learn that actually we have property. So we are creating a method, and we are creating, we are passing to this method reference to the representation of the method. Let me stress that here is something we can see it is equals. What did equals mean and where is defined? It is our next next question, but it is, you can see the similarity. So the converter, if you are going to convert it manually, you must convert this one that looks like expression into the delegate. It's also expression, but here we can see that return value it's Boolean, but here we can see that the expression returns delegate, reference to the delegate. Next, how to prove that we are using a link to SQL. To provide and answering to the previous question, how to implement access to the new external data repository. Let me go once again to the definition and this type. Go to definition. So here we know that person is of table type. Table, go to definition, implements IEnumerable, but additionally it implements iQueryable. And it is required. Implementation of the iQueryable, it is a condition that we are talking about access to the external databases. We are talking about converting the expression. Let me recall that language integrated query, the expression of the language integrated query returns a tree of operations, returns actually converted expression into the tree, so we call it the expression tree. It is not executed. It will be executed later, depending of implementation or iQueryable. If we have implementation of the iQueryable, we have possibility to convert this expression tree into the external representation of the same expression. Here we can convert it to the select SQL query. If you are using language integrated query, we can convert. So implementation of the iQueryable, it is required to provide. But there's difference between inheritance, implementation. So let me go back to the definition, to this catalog. Do you see that here we are returning IEnumerable? We are not returning iQueryable. Of course, it doesn't matter, because the most important thing that we must implement iQueryable. But if we need only implementation of IEnumerable for the user of this property, of this method, for this method is enough. We are using the type only to make sure that the type returned from the method is compliant with what we are expecting. Where we are using this syntax? Find all references. Are you following me? Maybe I should switch the webinar to the meeting, and now you can use your mics and ask me question directly. There's only, we are below the limit, therefore we can use it, this type of webinar. From the list, we can say that we are using it in the unit test, in the test method. What we are doing here, you are returning IEnumerable from calling this method. It is method syntax, but here let's back to the query syntax. As I said, it's easier. So now we are providing a parameter, a required parameter, and getting back IEnumerable. What is here in this variable? In this variable, as I said previously, we don't have any value. We have representation of the expression. How to prove it? In the next line, we are getting type. And here we are checking that the type is something like, that the type comes from the system data LINQ data query. But we are expecting, at the end of the day, we are expecting strings, just a table of strings. Because we are selecting values here, so we are expecting, we are expecting, here we are expecting enumerable of persons, a set of persons. But here we can, it is like a, for example, say, let's it's table of persons, but from this we can guess that it is something different. Of course, it is implementation of iQueryable, but it must be concrete type to use it in the program. To create the object, we need concrete type. Therefore, this type is defined inside the framework and it's provided for us. But in the next line, we can use toString for this variable. And in this string, we can prove that actually the value, it is selection, it is query. Similar query we can find in here, it's this query, SQL query. So now we can compare it manually. I'm splitting the screen so you can say that we have select and the rest is very, very similar to this query. It's exactly the same. Probably I have copy paste this query from this code to the SQL query. It is exactly the same. So we are proving that that the content, it is SQL query, not the value, selected value. It will change after calling this method, filtered.count, because now we are returning concrete value, so we must know how many items we have in this enumerable. Therefore, here we must execute. But how to prove that we must execute SQL? Here in all of the cases, we are calling the method that calls getEnumerator. We discussed it during the previous lecture. We are calling getEnumerator, and getEnumerator calls all the methods required by the iQueryable, implementation of the iQueryable. And finally, it must create query, send the query to the database and get back the data. After getting back the data, we can learn that there is only 2 items in the database. Now we can enumerate all of the persons in this enumerations. So here we have, actually here we have selected it looks very similar to the previous example, but uh, it is good example that we have divide execution of the operation on the database by in the first step we are selecting the data, and the second step we are only provide an operation, execute an operation against the selected values. So I think that is all we can say about the language integrated query. You can examine this code. Additionally, there is very useful text where we are using anonymous type. Here we also additionally we are testing that we have attributes, appropriate attributes. So this is the method shows how the object relations mapping have been implemented using attribute programming, using attributes, prefixing all the definition by the appropriate attributes. We are providing a relation between mapping between the database and the construct in the language. The last thing I have on my topic for today, it's not related directly to the language integrated query, but it's related to the testing and using the databases. As I said previously, we can use three scenarios. First scenario is that we can use real database, and we can get access to the real database. So get back to the definition, get back to the questions, what information must be provided by connection string. Because I'm asking the question, how to prove that your program refers to the real database, that your program are getting access to the database data, that all the operations that you have defined in the code are executed against the database. This information we can get from the connection string and from the implementation of the iQueryable and definition of all of the operation in the context of the representation of the database, in the context of the ORM. Let's get back to the connection string. Here, maybe in this, no. In this project, usually, if you are talking about testing data, you must provide the testing data in the testing context. It must be provided by the project unit test project. In many cases, you are providing access to the databases in the library, structured data, for example, in the data layer. It is wrong. It is wrong because the library must be universal. The library must be, you must imagine that you are distributing the library to the many users, and the users must use your library against any database, not only the database that is provided embedded in your project. Therefore, the database we are testing against the program must be provided in the in the unit test. And this example is exactly here. Here is CD catalog database. I have defined in-memory database. It means that the database it's defined in the file, and during the testing I am creating the database, and after creating of the database, all operation is executed against this database. How to prove it? It's a good question how to prove it. First, we can use the environment, the design environment, the development environment to get connected to this data, to this data. How to create in-memory database? Just use add new item, data, and it is service-based data. This creates an empty data. But after double click on this database in the Server Explorer, okay, it doesn't work this way, but this way on this Server Explorer we can find connection to this file. I can connect to it. Something close connection. No, it's connected. It is connected. So additionally, you need to create the structure of the database here manually to provide the appropriate structure for testing data. But of course, answering the question, if you are using this database, we must find the connection string. Where is connection string? Because the data is provided in the unit test, we cannot provide connection string in the library because the library is not aware where the connection string, where the database is located, what kind of the database we are using. Therefore, we must find the connection string. We must use connection string here in the unit test. And in this project, the connection string is generated in the method class initialization method. Actually, in this line, connection string, it is common. This property, I expect private property. Go to pick definition. Może this way it'll be easier. Pick definition. No, you can see it is just a field. It's variable. It's local variable in this file, in the same file. So here we are creating this connection string, but creating of the connection string is not enough. First, from the connection string, we can learn three things. I ask about it. First, it is what is the database? Source is local DB, and kind of the data. What is the kind of the data of the database? Second is location of the database, and the next it is how to connect, how to provide information to the connection. Do you remember that there's additional parameters, connection timeout, for example, but it is very important to make connection, because as I said, during the connection we must to execute two operations. First operation is authorization, so we must define authority, we must define identity. Second, we must answer the question if this identity can create session, if it's allowed to for this identity create session in this database. What did it mean integrated security? Integrated security in this context mean that we are using all the data related to the identity that is embedded in the local session of the computer, because here I have also created a session with my computer, with my virtual machine. I have connected to my virtual machine, and I have actually, it's exactly the same operation. I must to authorize. Before authorization, I must to prove my identity. So authentication and authorization. Two operation is required to get connected to the database. After connecting to the database, we are using the same identity all the time to prove for the authorization all of the operation that we are going to execute against the database. So the type of the database, second is the location of the database, how to get access to the database. Here we can see that it's attached database, and here is the path. It is part of the connection string, but it's not enough to prove. The next thing it is how the connection is created. Here we can see that we are passing the connection string to the constructor of the catalog data context. As you remember, catalog data context is auto-generated class that we are using as a representation of the database. Therefore, we can prove that the catalog data context can use this connection string to get connected to the local database, and the connection string is defined where the database is created. Additionally, we must explain. I must explain why. Do I have time? No, it is just last question, last problem. Why we need to create connection string in a dynamic way? Because the testing environment can locate the testing environment in many places. Therefore, each execution of the test creates new working space for the test, and we need the link. We need to path to this working space here to create the appropriate path where the file defining the database is located. To make this file available in the testing environment, we are using this deployment item to say the testing environment how to copy this file into the testing environment. Okay, I think that's all for today. So let me stop the recording and